Okay, very good afternoon, students. Today we will see analysis of structures by using the second method. It's called the method of sections. So they have given a problem to determine the force in members AD, CD, and CE of the truss shown. So as we discussed in the class, so if we want to calculate or determine the force in members, particularly AD, CD and CE, any specific members if we want to calculate means. So instead of going for method of joints, we can go for method of sections. So as discussed in the class, we are going to solve this particular problem by using method of sections. In the given problem at point B, you can see it's a roller support. So this particular roller support will have only one reaction, that is By, that is along vertical direction. Next one, if you see at point K, you have pinned support or hinged support. So as we discussed in the class, the pinned or hinged support will have two reactions. One is vertical reaction, that is Ky, and then it will have a horizontal reaction, that is Kx. Okay, the direction and all we are assuming. While we are calculating, if we are getting a positive value, our assumptions are correct. If it is coming in negative values, then our assumptions are wrong. Okay. So, and then you can see the external force 20 kilonewton is acting at point G, and then another 20 kilonewton it is acting at point D, and then there is a horizontal force acting towards left at point A, that is 36 kilonewton. And you know the height of the truss is given from K to J, that is from B to A also, 2.4 meter. And then you can see the distance between A to D is 4.5 meter, and then A to J is 13.5 meters. Free body diagram. So you know that we are having the reaction at B point, that is vertical reaction. I am giving as By. And then at point K, we are having a vertical reaction Ky and Kx. And then we are having external force 20 kilonewton at G point, and then 20 kilonewton at D point, and then 36 kilonewton at A point. Okay. So without support, if you are drawing the diagram with only forces, reaction and the dimension, then the diagram is called as free body diagram. So now we are going to find the reactions. So you know that we are having three unknown forces here, that is reaction forces By, Kx and Ky. So we can take moment about B so that we can calculate Ky, otherwise taking moment about K so that we can easily identify what is the reaction at the point B, that is By. So here taking moment about K. So once I am taking moment about K, so obviously the forces which are acting at point K, the moment because of Ky and Kx will be equal to 0. As we discussed in the class, so we are going to take that clockwise moment is positive with respect to the point K. So at point G, we are having 20 kilonewton. The perpendicular distance from the K point is 4.5 meter. We are fixing the truss at K and we are applying 20 kilonewton at point G. Definitely that particular truss will rotate in counterclockwise with respect to K. Similarly, at point D we are having 20 kilonewton, and then from the K point the total distance is 4.5 meter plus 4.5 meter, so totally 9 meter. So this 20 kilonewton will create again a counterclockwise moment, otherwise anti-clockwise moment with respect to K. So the next force is 36 kilonewton. So with respect to K, the perpendicular distance of this particular 36 kilonewton is 2.4 meter. Again this force also, if we are fixing at point K and then we are applying a 36 kilonewton at point A, the truss will rotate in counterclockwise or anti-clockwise. And then one more force we are having in this truss, that is By. A vertical reaction at B is acting towards up, and then we are holding at point K, and then we are applying a force at a distance of 13.5 meter, that is the perpendicular distance with respect to K for the force By. So obviously this particular force, that is By, will rotate the entire truss in clockwise direction. So we are going to take that as positive. So as discussed, so this is the equation. So as we are considering the truss is in equilibrium, so we are taking the summation of moment about point K is equal to 0. So after calculating the moment due to the 20 kilonewton which is acting at G, that is counterclockwise, so I have substituted minus 20 multiplied with the distance from K point, that is 4.5 meter. And then the another external force which is acting on point D, that is 20 kilonewton, and from the point K, the perpendicular distance of that 20 kilonewton which is acting at point D is 9 meter. So again I have substituted minus because it's a counterclockwise moment or anticlockwise moment. The third one is a horizontal force which is acting at the point A, that is 36 kilonewton. From the point K, the perpendicular distance of that particular 36 kilonewton force is 2.4 meter. This force is also creating a counterclockwise moment, so I have substituted in minus. And then the final one, that is the reaction force at B, that is By, which is acting towards up. With respect to K, the total distance of the force is 13.5 meter, and then this force is creating a clockwise moment in the system, so I have taken as positive. So once we are substituting this and then equating to 0, then we will calculate the value of By, that is 26.4 kilonewton. So based on our calculation, the answer what we got in positive, so our assumption is correct, that is By is acting upwards. So next one, after calculating the reactions at point B, that is By we have calculated. Now we are going to calculate the reactions at K, that is Kx and Ky. So Kx is related to the horizontal force component. So we are having another equilibrium equation, that is, you know that summation of forces acting along x direction is equal to 0. That is acting towards right side is positive, we are taking. So you know that Kx is acting towards right, so it is positive, and 36 kilonewton is acting towards left, that is negative. So if we are substituting, then it will be Kx will be in positive and 36 kilonewton will be in negative. So summation of forces along the x direction or horizontal direction, Kx minus 36 is equal to 0. So based on that we can get Kx is equal to 36 kilonewton. Okay. So our assumption is correct, that is it is acting towards right side. So next one, to calculate the reaction at K point, that is Ky, we are substituting the next equilibrium equation, that is summation of forces along vertical, that is y direction, is equal to 0. That is, we are assuming acting upward as positive. So you know we are having the reaction Ky, which is acting upwards, and then we are having a reaction at B, that is By, that is also acting upwards, and then the external force 20 kilonewton is acting towards down, and another 20 kilonewton which is acting at point D is also acting towards down. So if we are substituting in this equation, that is third equation, summation of forces along y-axis is equal to 0, then Ky and By will be in positive, and 20 kilonewton at G and 20 kilonewton at D will be in negative. So you can see the equation, By plus Ky minus 20 and minus 20 is equal to 0. We have already calculated By, that is 26.4 kilonewton. So if we substitute By is equal to 26.4 kilonewton in the equation By plus Ky minus 20 is equal to 0, we will get Ky as 13.6 kilonewton. Again our assumption is correct because we got the answer in positive. So now we have calculated all the reactions, that is By we have calculated, that is 26.4 kilonewton, and Kx we have calculated, that is 36 kilonewton, and Ky we have calculated, that is 13.6 kilonewton. So after calculating the reactions, now we are moving to calculate the member forces as per given in the problem. So they have asked us to calculate AD, and then they have asked us to calculate CD and then CE. So the forces which are acting on AD member and then CD member and then CE member, they have asked us to calculate. The section line should cross 3 members, and the section line should intersect the members where we are going to calculate the forces. For example, we are going to calculate the member force in AD and in CD and then member force in CE. So we have drawn the section line like this. So after drawing this, we are going to draw the free body diagram. So I am taking the point A, and then we are taking the point B, and then we are taking the point D, and then we are taking the point E. A center is the point C, so we are taking the point C also. And then we know that the members we have to join, that is AB, AC, and then BC. So these members we have drawn according to the section lines, okay? Because the section line is intersecting after the point C, and then you know that it is intersecting the member AD, the member CD, and then member CE. So as per the principle of method of sections, we are following it. So after that, you know that the AC and then CE member is on the same line, and then the BC and then CD is also in the same line as per the given problem. So the members are in line. It is having a common axis. And then we know that the distance between A to B is 2.4 meter, and then the distance between B to E is 4.5 meter. So now with respect to point C, the distance of point C with respect to A is 1.2 meter, and with respect to B is 2.25 meter. So now we have drawn the members AC and BC and then AB. So they have asked us to calculate the member forces AD and then CD and then CE. So now we are going to draw the member forces and external forces and also reactions. At point A, so we are having an external force of 36 kilonewton, and then we are also having a member force, that is FAD. We are assuming that the force, the member force in AD is tension. According to that, we are drawing the direction of the force. Similarly, at point B, we have already calculated the reaction By, that is 26.4 kilonewton. And then we are having a force at point D, that is nothing but the member force FCD, and then we are having another force at point E, that is the member force of FCE. So hope you got everything clear now. So now we are going to calculate the member force of AD, CD and CE, okay, as per the given problem. So first we are going to calculate the member force FAD. So the given problem for your understanding, and this is the detailed sketch whatever we have seen in the previous slide. Okay. So now to calculate the member force AD, so if I am taking moment about point A, so obviously AD will be get cancelled because moment about that point will be 0, that is point A will be 0. And if suppose I am taking moment about B, I will get more unknowns, that is FCD also it will be unknown, and FCE also will be unknown, and FAD also will be unknown. So as we discussed in the class, maximum unknown forces should be less. So according to that, here we are taking moment about C. So if we are taking moment about C, you can see that the force which is acting along CD, FCD will be 0, because as per the principle of transmissibility, you can transfer the force FCD to C point, so obviously the moment about that particular point will be 0. Similarly, if you are taking moment about C, FCE also will be 0 as we discussed in the class. So the force which is acting along the line of C, So FCE also will be transferred to the point C as per the principle of transmissibility. So the moment about that point also will be equal to 0 due to the force FCE. Again, if we are taking moment about C, so you will have only three forces and only one unknown force. That is, you will have a force of 26.4 kilonewton, and then you will have a force of 36 kilonewton, and then you will have a force of FAD. So two forces are known and only one force is unknown. So we have to select a point such a way that with very less unknown forces. So only we are taking moment about C. So now we are taking moment about C. So we are assuming that clockwise moment is positive. So based on the equations, I can explain one by one. So with respect to C, as I said, we are having one force which is acting at point A, that is horizontal towards left side, 36 kilonewton. That particular force is acting with respect to point C at a distance of 1.2 meter. That is the perpendicular distance with respect to point C. So this particular force, 36 kilonewton, will make the truss to rotate in counterclockwise or anti-clockwise with respect to point C. So minus 36 into 1.2 is given. Okay, this is the thing. So it is a counterclockwise. So we are substituting as negative. Next one, if you see with respect to point C, the next force is at point B, that is 26.4 kilonewton. And this force is acting with respect to point C is 2.25 meter. So this particular force make the truss to rotate in clockwise direction with respect to point C. So we have to take it as positive. So plus 26.4 multiplied with 2.25 meter. Okay. And the final one, which is unknown, that is FAD. So which is acting at point A. So again the perpendicular distance will be the same, 1.2 meter. This FAD force is making the truss to rotate in clockwise direction, so with respect to point C. So we have taken as positive, that is FAD multiplied with 1.2 meter. So all these things, as we discussed earlier, it is the system is in equilibrium, so we are equating to 0. So once you are substituting it, we can easily calculate the value of FAD. So as per the calculation, we are getting it as minus 13.5 kilonewton. So compressor force, not tension. So now we have calculated FAD, and the remaining things we are having FCD and then FCE. We are going to calculate the member force at CD. So now if we are taking moment about C point, then obviously CD and CE will get cancelled. So now we have to go with other point. So I am going with the point A. Okay. So if I am taking moment about A, so obviously the FCD will have two component, that is FCD cos theta and then FCD sin theta, because it is the force which is acting at point D is actually inclined. So we have to calculate the theta. So as we discussed, summation of moment about point A is equal to 0. Again we are assuming that the clockwise moment is positive. So I am taking moment about A. So 36 kilonewton will be acting at point A. So obviously the moment which will create 36 kilonewton will be equal to 0, because the perpendicular distance with respect to point A for the 36 kilonewton is 0. And next one, FAD force is there. So again similar to 36 kilonewton, the perpendicular distance of the force FAD with respect to point A is 0. The moment due to FAD will be equal to 0. We are having a force at B point, that is 26.4 kilonewton. This particular force is also can be transferred to point A, that is also lying on the same line of action as per the principle of transmissibility. So the perpendicular distance is equal to 0. So the moment due to 26.4 kilonewton is also 0. So next one, FCE. So you can see that along AC and CE, so with respect to point A, the force FCE is also acting along the same line of action as a member force. So this force also can be transferred to point A as per the principle of transmissibility. So this force also is acting at point A. So there is no perpendicular distance. So obviously the moment created due to FCE also 0. So already we have discussed in the class. Again I am discussing the same in this video. Okay. So only the force which will create moment as you are having FCD. In that FCD also you are having two components. One is horizontal, another one is vertical. We will see one by one. So you have to calculate the theta. So to calculating theta, it's easy. That is tan theta is equal to, you can say 2.4 divided by 4.5. You will get the value of theta. So theta is equal to tan inverse of 2.4 divided by 4.5. But here we are having only one force. So we can directly substitute. So because I am taking that inclination as theta, so our horizontal component will be FCD cos theta and our vertical component will be FCD sin theta. So as we discussed, we know that the moment is force multiplied with the perpendicular distance. So with respect to point A, the perpendicular distance for the force FCD is 4.5 meter. For FCD cos theta, again it's similar to 36 kilonewton. It is acting on the same line of action with respect to A. So FCD cos theta will not create any moment with respect to point A. So only the force which is creating a moment is FCD sin theta with the distance of 4.5, that is the perpendicular distance with respect to A, and it is rotating in counterclockwise, that is anti-clockwise. If I am holding at point A and then if I am rotating the truss, because of the force FCD sin theta, it will rotate in counterclockwise or anti-clockwise. So now we are having an equation. So minus FCD sin theta into 4.5 is equal to 0. So you know that we got only one force component and then perpendicular distance 4.5 and it is rotating in counterclockwise, so I substituted minus. So obviously the force of FCD will be equal to 0. So this particular member is called a zero force member. That is CD is called as zero force member. We have calculated FAD. Now we have calculated FCD. Next we are going to calculate the member force at CE, that is FCE. So again the given problem and then the free body diagram. So obviously we cannot take moment about here. The force FCE is in the same line of action. So we cannot take moment with respect to C also. So we are having the point D. So we are taking moment about D. So as like A. So here you can see that summation of moment about D is equal to 0. Again we are assuming that clockwise moment is positive. If you are taking moment about D, the FCD is acting at the same point, so the moment value will be 0 due to the force FCD. And then we are having 36 kilonewton, so it is also in the same line of action, so the moment value will be 0 with respect to point D. And FAD also, it is in the same line of action, so the moment value will be 0 because there is no perpendicular distance with respect to point D. Then we are having a force B now. So now the force of 26.4 kilonewton is having some distance, perpendicular distance with the point D. That perpendicular distance is 4.5 meter. So if I am holding at point D and then if we are applying a force at point B, force 26.4 kilonewton will make the truss to rotate in clockwise if I am holding at point D. So it's a clockwise moment, so it will be positive. And we are having another force that is FCE. It is acting inclined. So it will have a two component. So we have to calculate the theta. So as I said earlier, so we can calculate tan theta. So tan theta is equal to now 2.4 by 4.5. So we will get the value of theta is 28.07. With respect to point E, we will have FCE sin theta, that is the vertical component, and then we will have FCE cos theta. If you see FCE sin theta, it is also acting along the same line with respect to D. It is not having any perpendicular distance with respect to the force FCE sin theta. So the moment due to FCE sin theta will be equal to 0. But if you take FCE cos theta with respect to point D, it is having a perpendicular distance. That perpendicular distance is 2.4 meter. And if I'm holding at point D and then if I'm applying a force FCE cos theta, definitely the FCE cos theta force will make the truss to rotate in counterclockwise. So I have to assume as negative. So we are having only two moment, that is due to 26.4 kilonewton at a distance of 4.5 meter from the point D is rotating in clockwise direction, and another force, that is FCE cos theta with respect to point D, the distance is 2.4 meter, that is making the truss to rotate in counterclockwise. So one is positive, another one is negative. So you can see that 26.4 into 4.5 is positive as we discussed, and FCE cos 28.07 multiplied with the 2.4 is counterclockwise moment, so I was substituted in negative. Okay, so once you are substituting, easily you can calculate the FCE value is equal to 56.1 kilonewton. So we got in positive, that means the force which is acting on the member CE is in tension. So hope you understood. We will meet in another video. Have a nice day.